Hey everyone, have you ever looked at one of those incredibly fluid, complex 3D shapes and just thought, how? How is that even made? Well, it's not magic, I promise. Today we're going to pull back the curtain on one of the most powerful tools in any designer's toolbox. Let's get right into it.
I mean, just look at this thing. It's so intricate, so smooth. You've got all these surfaces flowing into each other. So how do you start? Do you have to meticulously sculpt every single curve and surface by hand? You could, but there's a much smarter way to work.
And here's the secret. All of this complexity actually comes from something incredibly simple. It all begins with just a handful of basic curves, and then one single powerful command that brings them all to life. And that command is called the loft.
So here's what we're going to cover. We'll start with the basic idea of turning curves into surfaces. Then we'll jump into the Grasshopper blueprint and tackle the most common mistake people make, that dreaded twist. After that, we'll get into styling your surfaces, handling more complex data, and finally, we'll talk about the real secret weapon, associativity.
Okay, first things first. What is this tool actually doing? What's the fundamental idea behind lofting?
You know, the concept is actually beautiful in its simplicity. I want you to picture the ribs of a boat's hull, or maybe the cross-sections of an airplane wing. The loft component takes a series of those profile curves, those ribs, and it stretches a perfectly smooth digital skin right over them. It connects them all into one single, continuous surface.
And this image right here, it just shows that idea perfectly. You can see those input curves, the circles, acting like the skeleton of the shape. The loft component then intelligently figures out all the space in between them to generate that final, elegant form. The curves are the instructions, the lofted surface is the beautiful result.
Okay, so we've got the theory down. Now let's see how this actually plays out inside Grasshopper. How do we put this whole thing into practice?
So in Grasshopper, everything really boils down to two things: parameters, which just hold your data, and components, which perform actions on that data. So you start by referencing your curves from Rhino into a parameter. That's your data. Then you just plug that data into the loft component. That's your action. Data flows in, geometry comes out. It's really as simple as that.
All right, now we have to talk about this, because this is the exact spot where almost everyone gets stuck the first time they try to loft. You plug in your beautiful curves and you get a complete mess. So let's tackle this common pitfall head on.
Does this look familiar to anyone? Yeah. You were expecting this nice, smooth surface, but instead you get this bizarre, twisted, self-intersecting disaster. So what in the world is going on? Well, the loft tool is actually doing exactly what you told it to do. The problem is, your instructions were accidentally all out of order.
See, every single curve has a starting point and a direction. We call that its seam. The loft tool tries to connect the seam of one curve directly to the seam of the next one. So if those seams aren't lined up, the surface is going to twist all over itself trying to make that connection. The key takeaway here is alignment is everything.
And honestly, the best advice comes straight from the source material. It's a simple rule of thumb. Whether you're clicking on curves in Rhino or organizing them in Grasshopper, you have to make sure their start points and directions are consistent. By picking each curve near the same corresponding end, you're basically giving the loft command a perfect, untangled roadmap to follow.
Okay, so once you've gotten the hang of that and your lofts are coming out clean, it's time to add a little finesse. Because the loft component isn't just a one-trick pony. It actually gives you options to control the whole character of your final surface.
And this really highlights an important trade-off you get to make. The default style, normal, is super precise. The final surface will pass exactly through your input curves, guaranteed. But the loose style does something totally different. It uses the control points of your curves to define the control points of the surface. The result is often a much smoother, more flowing form, even if it doesn't hit your guide curves exactly.
And here's a perfect example of what that loose style looks like in action. Just notice how gentle and continuous that surface is. What you're doing here is trading a tiny bit of pinpoint accuracy for a whole lot more organic smoothness. It's a really powerful choice to have, depending on what you're trying to design.
Okay, so lofting one set of curves is one thing, but what happens when your design starts to get more complex? What if you need to manage multiple lofts all at the same time?
Right, so let's say you have several different groups of curves. Maybe you're creating the fingers on a hand, or the columns on a building. You want to loft each of those sets individually, but you want to do it all within the same Grasshopper definition? How do you manage that kind of data?
Well, if you just dump all your curves into one giant list and plug that into the loft component, it's going to try and connect everything to everything else. You'll just get this one massive, chaotic surface that links all your separate parts together, and that is definitely not what you want.
The solution is this amazing little component called Graft. The easiest way to think about it is that it puts each of your sets of curves into its own separate folder. When you plug all these folders into the Loft component, it's smart enough to know that it should only create a surface between the curves that are inside each individual folder. This is the absolute key to keeping your data organized and working at scale.
And all of this leads us to the final, and I think most profound concept of all. The Loft component itself is powerful for sure, but its true magic is only really unlocked by the core philosophy of Grasshopper itself. So here we have a complete definition. We've got some curves, maybe we've set their radii, and we've lofted them together into a final shape. Now, in traditional 3D modeling, this might be the end of the story. You have your final geometry, and that's it.
But in Grasshopper, nothing is ever final. This visual network of components isn't just a recipe for how the shape was made, it's the shape's living, breathing DNA. The entire design history is laid out right in front of you, and crucially, it's live.
This is what we call associativity, and what it means is if you go all the way back to the beginning of the chain and change anything, the result updates automatically in real time. Move one of the original curves, the lofted surface instantly reforms. Tweak a radius slider, and the whole model breathes and adapts with you. This completely changes modeling from a linear step-by-step process into something dynamic and exploratory. So, you see, the loft isn't just a tool for making a single static shape. It's a component in a living system. A system where you don't just build an object, you build the logic that creates the object. And when you can do that, the whole question changes from what can I build to what can I empower my designs to become? So now that your designs can evolve in an instant, what will you create?